Hello everyone, thank you for being there today. I'm Aurélie Baker, I'm the ESABIC Sud France manager. I'm very glad to be there today with Guillaume. We are running in frame of ESABIC Sud France a series of webinars where we are presenting our alumni. And today we are glad to welcome Vortex. So Guillaume, I'll let you the floor.
Thank you, Aurélie. Hello everyone, I'm Guillaume Valladeau, CEO at Vortex IO, and I will present you today a simple but concrete topic, which is to keep an eye on our river anytime and anywhere. So Vortex IO is a young startup created 3 years ago with my co-founder Jean-Christophe Poisson. We are former employees of a subsidiary of CNES in Toulouse, and we were working for 15 years on mean sea level rise and study of mean sea level thanks to satellite altimeter data. And what we decided to create with Jean-Christophe is a technology transfer from space altimetry to hydrology to provide new observing systems for rivers at high risk for floods and drought risks. So extreme flooding events are rising, as you may all know, and there is an increased worldwide need for hydrological real-time monitoring solutions. We've got here some figures about the consequences of flood events in Europe. And this increasing worldwide need for real-time monitoring solution is the consequence of the current in situ state-of-the-art solutions, which you can see here on your screen, and which are for some of them outdated, and they are not scalable at a worldwide scale. That's why up to now, only a few worldwide watercourses are well monitored with real-time monitoring solutions. And the goal for Vortex.io is to provide a new in situ constellations of sensors, of innovative and smart sensors that we call the microstations. And thanks to these sensors, we offer a real-time hydrological monitoring and notification service. So we develop an hydrometeorological database anytime and anywhere. So our innovation is twofold. We developed an innovative sensor, an innovative in situ sensor inherited from space altimetry. And we also set up a disruptive distribution model that I will show you some slides just after this one. So first of all, the innovative sensor that we call the microstations. You can see here one picture of the sensor installed below bridges. This sensor is very compact. It is about 400 grams and 10 centimeter size. This is a completely autonomous sensor, which is power supplied through a solar panel and the battery on board. And also in terms of connectivity, we've got a twofold transmissions for the data, which consist in GSM connectivity, but also a new and innovative satellite solutions, an IoT space solutions called Kineis, that you may also know because this is a French solution. And this is very important for us because what we want to provide on our side is real-time data. So that's why considering only GSM connectivity was insufficient for the needs of our customers and our clients. So we decided to provide also space transmissions for the data. And this is the same for the power supply. The solar panel is enough to have an unlimited autonomy on board the microstations. But in case of event on the solar panel, we've got the battery that provide also power supply for the microstations. Considering the sensors that we've got on board, we have a LiDAR sensor plus a camera. And thanks to these two sensors, we are currently providing water level measurements with centimeter accuracy, but also water surface speed velocities and images in real time. These real-time measurements will be complemented in the close future thanks to new hydrometeorological parameters that are very relevant for the study of hydrological surfaces as well as for atmosphere. In addition to this sensor, we decided to develop a new distribution model through a SaaS platform. Our SaaS platform is called MAELSTROM. You can connect on the site, website, and you will get some demo sessions of what we can provide in real time. And you've got here some examples of what we provide in real time. So you've got the water surface 8 using the LiDAR solution. And you've got also the images and the computation in real time of the water surface velocity, thanks to the combination of the LiDAR and the camera. And what is very interesting is that you've got all the historical database through the MAELSTROM platform, and you can be committed through the different stations that you are interested with on your side. And this Vortex IO network, in situ network, is now complemented thanks to new or existing networks, in situ networks. And in addition, we also provide drone measurements. And I will present you some slides of our product line embedded on flying UAV, and also satellite data over rivers and lakes. So this is a real marketplace that you've got with MAELSTROM, and thanks to this marketplace, you can have access to a threshold that you can put for alerting and notification services in case of flood events, in case of drought, or in case of water resources management in general. Here you've got an example of what we were currently providing 1 month ago over the Garonne River. Up to now, we added 4 new sensors close to Agen over the Garonne River. Our goal is very precisely monitor the Garonne River in complement to the current existing networks. And this is a snapshot of the MAELSTROM platform, and you can see that thanks to this platform, you've got an all-in-one marketplace, a turnkey service, where you can select your stations, you can add the stations in the basket, and you can have quotations in real time. You can sign these quotations, and you can be committed. You have an access to the platform with a subscription form. The second use case, the second product line that we provide on Vortex IO side is the Vortex IO light altimeter sensors. This is a very useful sensor in complement to the in situ fixed microstations. The technology is closely the same that the microstations, but in addition to the microstation, we've got also on board a GNSS, a very precise GNSS positioning system. Thanks to this GNSS positioning system, we can embed the light altimeter on every drone capable of carrying 1 kilogram payload. We've got also a LiDAR and a camera, but the LiDAR is quite different from the microstations, and I will present why just after. And with this sensor, we've got an autonomy of about 3 hours for the payload. So depending on the autonomy of the drone, we can perform a very long liner over rivers, for instance. Considering the hydrological parameters that we provide, thanks to these stations, we are providing right now water level measurements also with a centimeter accuracy, and also orthophotos. We provide 1 photo per second on the stations, and thanks to that, we can have a good complementarity between the water level observed and flooded areas, for instance. Last but not least, thanks to the LiDAR, we can perform overflight up to 90 meters range, which is very interesting to observe pretty large rivers and have a well-observed liner of these rivers. Considering the LiDAR, the payload itself, the LiDAR is a swath of 8 beams that provided in real time all the water surface 8 dedicated to measure the rivers. And we've got a precise positioning system using a GNSS PPK processing. So we need a base, but what is very interesting on our side is that when positioning the ground base, the ground stations, we can perform centimeter accuracy overflight up to 70 kilometers from the base. So we can provide very long distances with this overflight, depending for sure of the regulations over the countries that we deploy the solution. This drone solution is routinely used with CNES, but also ESA and also other space agencies for calibration validations activities of satellite altimetry. What is CalVal? This is the comparison, the direct comparison between the track of a satellite over the rivers that we call the virtual station, and the comparison with the in situ measurement that we provide with the microstations or with the drone overflight. So you can see that in terms of use cases, with the drone solutions that we provide on Vortex.io side, we can have a direct CalVal mean. That is to say that we deploy the same day that the track of the satellite, the drone over the rivers, and we've got a direct comparison between the drone measurements and the satellite data. But also we can have an indirect CalVal mean for space agencies that consist in measuring the river topography between an in situ station, for instance, the microstation, but we can consider other in situ networks, and the actual virtual stations, the crossover between the satellite track and the river, and we can perform it when we want. We use these solutions for CalVal activities with CNES and ESA for about 3 years now, and we perform different deployment over French and European rivers, and also over the Geneva Lake for the CalVal activities of the Sentinel-3 and Sentinel-6 missions. And this solution is now considered for the oncoming SWOT missions over the Garonne River. So by complementing the stations that are installed in situ and the drone deployments, we can have a very accurate knowledge of the rivers. Here you've got the water surface 8 measurements that we provide over rivers. So the water surface 8 is of course measured by the LiDAR. So we perform some flights following the streams of the rivers, and there is a direct link, as you may all know, between the water surface signals, the water surface behavior, and images provided thanks to the Vortex IO light altimeter solution. And this supply of images is very, very useful to understand measurements over the rivers, to understand why there are some discontinuity between the measurements, between the water surface 8. As you may see here on your right on the map of water surface 8 along the Garonne River, you can see some discontinuity, and discontinuity are very well explained thanks to the images that you've got on the left side of the screen. So the combination between the instrument, the sensor dedicated to measure the water surface 8 and the camera is very useful to understand how behave the rivers that we want to observe. And this is very interesting also because thanks to this solution, we can measure the slope of the rivers that we overflight. And for instance, in some very interesting rivers in France, like the Saône River, we can see, thanks to such an accurate sensor, that the slope is close to 1 centimeter per kilometer, which is very, very a low slope. And finally, I wanted also to underline what we can provide in terms of artificial intelligence, and thanks to the use of the camera on board the light altimeter. So you've got here on the left an orthophotos provided by the Vortex IO light altimeter solution. Thanks to this altimeter, we've got a detection of the flooded area. And you've got here the automatic detection of the flooded area, which is performed thanks to artificial intelligence algorithm, which is provided on the right of the screen. So this is also, in this case, a combination with the water surface 8 measured by the LiDAR. So what is very interesting is to demonstrate the potential of such combinations of different sensors on board that when they are well complemented, they can provide very useful information for Earth observations in terms of hydrological data. And here you've got an example of what we can provide in real time for public services, but also for different mayors or other towns in France and worldwide, considering the way we can measure the arrival on the flood for different towns and for the prevention of populations. And thanks to that and the installations, the deployment of in-situ microstations, we can anticipate the occurrences of flood events, and we can have a dedicated protection plan for communities to prevent them for the consequences of climate change over continents. So this was an instance of what we are developing on Vortex.io side. Our goal, again, is to prevent communities from flood, drought events, but also to provide new measurements and complement existing networks for all the water resources management. And if you have some question regarding the presentation, don't hesitate. Thank you for your time.
Thank you, Guillaume, for this very interesting presentation. We got some questions. So, is the MAELSTROM service providing data only a station point? Does it also provide extrapolation or integrated product information, such as water debit estimates?
Okay, maybe we can we can go slowly through the different questions. So the first one was considering the management of the installation of the microstation?
Yes.
Okay, so as I explained to you, the Vortex.io service is a turnkey service from the installations of the stations on the field through the disseminations of real-time data. So yes, on our side, we don't sell the product, we sell the data, and we take in charge the way to install the station on the field. And when you install a station, when you ask us for installing the stations on the field through the MAELSTROM platform, the whole Vortex.io team set up the demand to public regulation authorities to install the stations on the bridge. And up to now, we've got 100% authorizations for installing stations because it's quite compact and very non-invasive for environment.
And the data provided are only on the station point? Or you get information along the river, or just where you put the station on the bridge?
Depending on the kind of product lines you will consider on Vortex.io, you will have, when considering only the microstations as they are installed below bridges, you've got only one point measuring below the bridge the behavior of the river. But when you perform drone overflight, you've got a complete liner of the rivers that provide in real time water surface height and also orthophotos.
And the last part of the question is about the extrapolation. Do you provide only information, or do you extrapolate the results?
Right now, the goal of Vortex.io is to deploy between 5,000 and 10,000 microstations all along the rivers in France and Europe. So right now, we provide only observations. It is possible that in the close future, thanks to this huge database of observations, we imagine to provide a very complete downstream services for which we need to extrapolate the data between two in-situ stations. But thanks to the drone solutions, we can make the continuity between the stations, as I explained during the presentations. So at the end, we have in mind to provide a very complete observation system of the rivers all over Europe.
Okay, and it's not possible to equip a whole river. So how do you choose a strategic point to put the stations?
This is a good question. Thank you for that. On our side, we use the complementarity between the different key indicators, geographical, political, and also what we have with the Earth observations technology to select in terms of priorities the rivers which are at a very high risk for flood events, for instance. And in France, for instance, there are close to 10,000 rivers which need real-time monitoring solutions to prevent at large scale flood events for communities. So there are many huge needs for these communities. So we select the priorities in terms of deployment thanks to the presence of communities for sure, but also some other indicators that are very useful for us to deploy the stations below the bridges. And considering the MAELSTROM platform, if you go on the website, you will see that we concatenate the global bridge database on our platform. And when you want to ask for an installation of stations, you have all the bridge that are available over the location of interest for you, and you can select the bridges on which you want to the Vortex.io that install the stations on the bridge.
Okay, we have another question. What would be the requirement for a satellite altimeter to replace the drone measurement? And is it potentially interesting?
No, I think that right now there is a huge complementarity between all the different technologies that are used for Earth observations. And what we defend on our side is that considering in situ stations, drone overflight, high altitude drones, nano satellite, and also space missions are very useful to go further in studying and explaining consequences of climate change all over Europe and worldwide. So I will answer that never. I think that the drone won't replace satellites in any case in the close future, because the advantages and limitations of the different technologies are very complementary. So for instance, with the satellite one, we've got a global coverage of the whole world in a few days, and this is significant for observation studies. On the contrary, with the drone, you've got to have the regulation authorities assessment for deploying the drone, and this is very complicated. You've got to face different actors with their own constraints. So it's very difficult especially for a small startup to deploy the drone everywhere in the world. But we are providing and we are making huge efforts with space agencies to deploy the drones in complement to the satellite. And second, I will say that if you think about flood events, for instance, considering only the satellite observations won't be useful enough, because when the flood occurs, there are 90% chances that the satellite won't be at the good locations at the good time. So having in complement in situ stations and also drone naval flight is very interesting and relevant to observe and prevent communities from these events. So at the end, what I want to underline is the fact that these different technologies are very useful, and I want to insist on the fact that it is very relevant to consider all these technologies for Earth observation.
And we have another question. So it isn't wrong detection of flooded area within the ellipse. So I don't know if you understand the question.
No.
No. So I try again. Isn't wrong detection of flooded area within the ellipse? Or maybe you talk about an ellipse somewhere in your pitches.
Maybe on the slide providing the detection, the contouring of the flooded areas. So the way we provide it is using artificial intelligence to provide a very reliable indicator for that. You've got to acquire a lot of data and perform a lot of use cases. I use these use cases because it was very interesting. We deployed the solutions during the events with strong rain and wind, and it's possible that using the first guess of our detection, there are some wrong detection in some small areas, but right now we've got 3 years of understanding of the fact that we compute with artificial intelligence this contouring and automatic detection, and we perform it in real time. And this is very interesting and useful for field teams, because they don't need anymore to be on the field to take some measurements and take some risk for them. For preventing the populations. And using the drones, you can be 1 kilometer away from the flood events, and you can observe and provide in real time some useful tools to prevent this population. So I think that even if there are more and more progress and improvement to perform to provide new indicators, this state of the art is very useful for field teams right now.
Okay, thank you. I think there are no more questions. Thank you for all the answers. Thank you very much. It was very interesting. So now we have to convince our municipalities to put to put monitor on our river. We have to spread the word. So thank you very much. Good luck for the upcoming steps, and we will be very glad to welcome you for this webinar.
Thank you, Aurélie. Thank you all.
Okay, bye-bye.
Bye.